This is standard 8.4, given a rational function in factored or unfactored form. Sketch a graph using asymptotes, holes, and intercepts, or going the other way around. If you're given a graph, can you write a function for the graph? All right, so the first thing that we want to do is look for holes in our graph. So we'll write our steps here. First step, find holes. And to find holes, look for factors that cancel. So if we look at our function here, the x plus 7's cancel. We're going to have a hole at the x value of -7. Now when we cancel, our new function is 3x times x minus 5 on top and x minus 2 times x plus 4 on the bottom. How do we find the y value for that hole? How do we find any y value? We plug in our x. So to find our y value, plug in 7 for x. We have 3, or rather -7 times -7 times -7 minus 5 over -7 minus 2 times -7 plus 4. This works out to 3 times -7 times -12 over -9 times -3. These 3 and this 3 cancels out, leaving us a factor of -1. And if we evaluate this, we have -7 times -12 on the top, which is 84 over 9. And that is 9 1/3. And so our hole has an x value of -7 and a y value of 9 1/3. So this is our first piece of important information. The second thing that we want to do is find your vertical asymptotes. We'll use VA for vertical asymptotes, and to find the vertical asymptotes, we use the denominator. So factors in the denominator that didn't cancel are x minus 2 and x plus 4. Those give us the vertical asymptotes of x equals 2 and x equals -4. So that is where our vertical asymptotes are located. Next, we can find, and it doesn't have to be in this order, we can find our x-intercepts. And the x-intercepts, we're going to use the numerator. So factors in the numerator that don't cancel are the 3x and the x minus 5. 3x gives us x equals 0. The x minus 5 gives us x equals 5. So that is where our x-intercepts are. We want to find our y-intercepts. So our y-intercepts, you want to plug in 0 for x. And when you plug in 0 for x, we get y equals 0. And then finally, we want to find our horizontal asymptotes. Let's put this here. And to find the horizontal asymptote, you find the limit as x approaches infinity for our function. So 3x times x minus 5 over x minus 2 times x plus 4. How do we find the limit as x approaches infinity? Well, if we take this expression and we expand it, we get 3x squared plus some trivial stuff on top, and x squared plus some trivial stuff on the bottom. And these are both growing at the same rate of x squared. And then if they're growing at the same rate, our limit is the ratio of the leading coefficients. So our leading coefficients are 3 and 1. So this limit is 3, which means our horizontal asymptote has the equation of y equals 3. All right, so let's take all of this information and put it together so that we can sketch a graph. 3, 4, 5, 6, 7, 8. And we'll start with all the information that we've determined, and then from there sketch or try to sketch what our graph looks like. All right, so we have a hole at -7, 9 1/3, 1, 2, 3, 4, 6, 7, 9 1/3, 1, 2, 3, 4, 5, 6, 7, 8. 9 1/3 is between 9 and 10, so somewhere around here we have a hole in our graph. Number 2, our vertical asymptotes. We have an asymptote at x equals 2, and another one at x equals -4. 3 x-intercepts, we have one at 0, and we have one at 5. 4 our y-intercept at 0, which is kind of redundant because we have an x-intercept at 0. And then 5 here, our horizontal asymptote, we said was at y equals 3. So here's our horizontal asymptote. Okay. All right, so what we want to do first is determine what's happening on the left side of our graph and the right side of our graph. So notice on the left side of our graph, we have this hole here. Our graph is going to lie either above or below the y equals 3. It can't do both, otherwise we wouldn't have a function. Because we have a hole in the graph up here, we know that the graph is going to lie above because that hole has to be included in our graph. And we want to use the asymptotes kind of as our guide. So we are kind of hugging our asymptotes, right, going towards both of them in that piece of the graph. Now, if we look on the right side of our graph, again, our graph's going to lie either above or below the y equals 3. And because we have a point below y equals 3, we know that our graph has to be there. And again, we're going to hug those asymptotes. We're getting closer and closer to them. The question is, what's happening in between? So we have really three different choices. Choice 1 is this in green. Choice 2 is this in red. And choice 3 is this in blue. Now we can eliminate the green one because the green one would introduce a y-intercept that doesn't exist. So it's not going to be this green option here. So is it the blue or is it the red? Well, in order to figure that out, we need to know, notice the blue and the red kind of overlap up to the x value of 0, but between x equals 0 and x equals 2, we're kind of not sure what's happening with our graph. Is it on the positive side here with the blue, or is it on the negative side with the red? So we're going to pick an x value between 0 and 2. So we'll pick an x value in this region. And a good one would be x equals 1. So if we choose x equals 1, we're going to do a little bit of a sign analysis to see if our graph is positive or negative when x equals 1. So if we plug in x equals 1, our numerator is 3 times 1, which is positive. And then we plug in 1 for the second x, so 1 minus 5, which is negative. Whoops, just a negative. And then we plug in 1 for the denominator, so 1 minus 2, which is negative, and 1 plus 4, which is positive. Sorry, I keep on writing -1. I just mean to write negative. And the product of the numerator is negative, the denominator is negative. Negative divided by negative is positive, which means that at x equals 1, our graph is positive. And so the red graph is not accurate, but it's the blue one instead. And so here's our graph of our function. All right, our second example's asking us to write the equation given our function. So let's put our function together. We know that it's a rational function. All right, what goes in the denominator? Well, that's determined by our vertical asymptote. So we have a vertical asymptote at x equals -3, which means that x plus 3 is in the denominator. We have a vertical asymptote at x equals 7, which means x minus 7 is in the denominator. Our numerator is determined by the x-intercept. So we have an x-intercept of -4, which means x plus 4 is in the numerator. We have an x-intercept of 1, which means x plus 1 is in the denominator. There are no holes in our graph, which means that there are no factors that end up canceling out. So those are the only factors in the numerator and the denominator. Lastly, we want a leading coefficient here. If we were to expand our expression, we get x squared plus some stuff in the numerator, x squared plus some stuff in the denominator. They're both growing at that rate of x squared. The ratio of the leading coefficients would give you the horizontal asymptote. Horizontal asymptote is 5, which means the ratio of the leading coefficients has to be 5. So this should be a 5 and a 1, which means that we need a 5 here in our numerator. So we've incorporated our horizontal asymptote with the 5, the vertical asymptotes in the denominator, the x-intercepts here in the numerator. You could look at the y-intercept and just verify that if you plugged in 0, let's do that, we get something in that region. So this is 5 times 4 times 1 over 3 times, I think I made a mistake. It should be x minus 1 here. So this is negative 1 over 3 times negative 7, which is negative 20 over negative 21, which is 20 over 21, which is almost 1, which is approximately where that y-intercept appears to be. So our y-intercept is confirmed as well, and this is the equation for our function. Again, this is standard 8.3, or rather 8.4, graphing and writing equations for rational functions.